Greetings. My name is Elizabeth Wade. I teach basic calculus for the mathematics department at Pellissippi State Technical Community College. This is topic 1 on limits and segment 1.1 on the definition of a limit. A limit is related to the height of a function. Consider the function f of x is equal to x squared. Note that the function height varies as x varies. For example, if x is -3, the function height, which is this vertical distance, is 9. If x is -2, the function height, this vertical distance, would be 4. So the height is constantly varying as I move across the graph. When I get to an x value of 2, the height of the function is 4. This can be found algebraically by substituting 2 into the function. F of 2 is equal to 2 squared, which is equal to 4. Note that when the values of x get close to 2, the function gets closer to a height of 4. For example, if I let the x values get close to 2 from the right side, then the graph or the function is moving in this direction, getting closer to a height of 4. If I let the x values get close to 2 from the left side, notice that the graph is moving in this direction, getting closer again to a height of 4. We say that the limit as x approaches 2 for this function is 4. In symbols, we would write this as the limit, LIM. Underneath this phrase, we write x with an arrow pointing to the right as x approaches 2 of the function x squared is equal to 4. Let's look at this function. G of x is equal to x to the third power minus 2x squared divided by x minus 2. First, notice that 2 is not in the domain of g of x. If you try to substitute 2 into this function, it would yield a denominator of 0, which of course is an undefined expression. If you look at the graph of the function, notice that there's a hole in the graph at x equal 2. However, we can still make the same conclusion. As we get close to 2 from the right side, we're moving in closer to 2. X is approaching 2. The graph is still moving in this direction, approaching 4. And as we get close to 2 from the left side, the graph is moving in this direction, still approaching a height of 4. So we can still state that when the values of x get close to 2, the function gets closer to a height of 4. 4, we could say, is the intended height of the function. So even though 2 is not in the domain of the function, the limit as x approaches 2 still exists, and we can still make the same statement: the limit as x approaches 2 of x squared is equal to 4. In conclusion, for any function f, the limit as x approaches c of f of x is equal to L means that as x approaches c, f of x approaches L. Let me draw a diagram that fits this definition. I'll draw an arbitrary function f of x, and I'm going to select an x value of c. As x gets close to c from either the right side or the left side, the function values would approach this position, which we're going to label as L. So we say that the limit as x approaches c for this function f of x is equal to L. We also noted that the existence of this expression, the existence of the limit does not depend upon whether the function is defined. So there could actually be a hole in the graph at x equals c, and the limit still exists. In the next segment, 1.2, we will look in more detail at the question, when does a limit exist? Well, that is it for this segment. Now you need to practice this concept by working similar problems. Good luck.